All right, in this video, we're going to cover objective number 2 for section 4.1, which is being able to find the composition between 2 points, okay? So let's click the sheet that says composition, and we're going to go right to this GeoGebra applet as an illustration of what it means to find the composition between 2 functions, okay? So in this illustration, you can see I have the function f of x that's linear, and the function g of x is quadratic, okay? And below those equations, I have the box checked for f of g of x, which is the composition between f and g, okay? And when I move the slider, it's going to show us exactly what it means to find that composition, okay? So we're going to start by taking an x value, and we're going to plug that x value into the function g of x, which is the inner function in this case. That's going to result in a y value, which is represented by the length of that purple line segment there. And now I'm going to take that y value and I'm going to turn it into an x value that I then plug in to the function f and get a resulting output, which is the y value represented by the length of that black line segment there. All right, so that shows the composition f of g of x. Let me check the other box and let's show g of f of x. Now really the only difference here is when you start with your x value, this time you're going to plug it into the function f first. F is now the inner function based on that notation. I take the resulting y value, treat it now as an x value to plug into the function g, the outer function. It results in a y value, once again represented by the length of that black line segment. All right, so there's a nice visual of what it means to find a composition, okay? Let's go back and look at our notes here. So understand that when you're working with a composite function or a composition between 2 functions, there's 2 notations that can be used. Okay, so you saw the one notation already used in the applet there, f of g of x. Okay, the other notation is what you see over on the left-hand side. You would read this as f composed of g of x. Okay, and I want you to pay attention to this symbol right here. This is an open circle. It is not a multiplication symbol. So don't confuse this with trying to multiply f and g together, okay? This represents a composition instead, all right? Now, the whole idea between the composition of 2 functions is that the range values from the inner function, which in this case is g, they become the domain values of the outer function f. Okay, so the y values from g turn into the x values from f. Okay, and the other really important thing to understand is what I have listed in red at the bottom here. Understand that a composition between 2 functions, it's an operation, just like addition, subtraction, multiplication, and division, which we saw in our last video. The only difference is compositions are specific to functions, okay? You cannot find the composition between real numbers. You can only find the composition between 2 functions, okay? All right, let's work through a couple examples. So in this example, I have 2 discrete functions, f of x and g of x, that are each just a small set of ordered pairs. And I would like to find f composed of g of 5, or that's the same as saying f of g of 5, okay? So I would start with the inner function, which in this case is g, and I would plug a 5 in for g as an x value. So I go up to the function g of x, and I look for a point whose x coordinate is 5, which of course is right here. What's the corresponding y value? Well, that would be 1. So g of 5 is equal to 1, and I'm going to substitute that 1 in here. So now instead of finding f of g of 5, I can think of finding f of 1. And f of 1 means go to the function f, find a point whose x coordinate is 1, which would be this point right here. Well, what's the corresponding y value? It would be 4. Okay. And ultimately what this is doing is it's leading us to a point of 5, 4 for the composite function. Right? I started with an x value 5 at the very beginning, and I finished with a y value of 4. Okay. All right, let's practice this in the applet linked below. And I want you to open this up yourself. I'm going to do one example with you to make sure we understand how this works. And then you're going to use it to practice, okay? So here, instead of listing out the points for each function, they've graphed the points of each function, okay? So you have pink points represent function f, and blue points represent function g. And I would like to find f composed of g of -1. Now, based on that notation, I'm starting by plugging -1 in for an x value in the function g. Okay, so I'm looking for a blue point whose x coordinate is -1, and that would be this point right here. The corresponding y coordinate to that point is -8. So now I take that -8 and I plug it in as an x value for the function f. Okay, f of -8 corresponds to this point, and it has a y value of -1, which would be my output. So I'm going to type in -1, I'm going to hit return, and notice it tells me that I am correct. Okay. So I want you to use this for just a minute or two, generate new problems, hitting the button down in the bottom there, and work through it until you feel like you've got the concept down. Okay, and then you're going to come back to this video and continue with the rest of the examples. Okay. All right, in this next example, the two functions that are given, these are continuous functions where I have the equation for each, okay? So I'm going to first find the function f of g of x, okay? F of g of x. And this will begin by just simply using substitution, okay? G of x I know is equivalent to x squared minus 3. So I'm going to substitute that in, and I'm going to evaluate the function f with x squared minus 3, which simply means in the function f, wherever I see an x, I replace it with x squared minus 3 and then simplify. That's going to lead me to -5x squared plus 22. So notice I'm getting an equation, in a sense, to represent the function f of g of x, okay? All right, now, second half of this example, I want to find f of g of 2, okay? And I want you to notice how I have a specific value inserted in for x now, whereas in the example we just completed, I didn't have a specific value, okay? When there's a number substituted in for x, that's my indication that my answer should be a number as well. If there isn't a number substituted in for x, that's my indication I should end up with, an equation in the end, like I have here, okay? So again, there's two ways that this can be found. The first would simply be find g of 2, which would be 2 squared minus 3, or 4 minus 3, which is 1. And now take that result of 1 and plug it into the outer function f. F of 1 would be 7 minus 5 times 1, which is 2. So there's your first option, okay? Or your second option is you could use the result from part A of this example to, you treat it like a formula, and you're going to plug 2 into that for x, okay? So that would look like this. Simplify, 2 squared is 4, 4 times -5 is -20, and we end up with 2 as well, okay? So you get the choice of which approach you want to take. I would say only take the second approach here if you had first been asked what we were in part A, okay? All right, now, once again, I want you to pause the video. You're going to practice on this next GeoGebra applet that's been linked, okay? I think that one's pretty self-explanatory, so I'm not going to show you an example on that one, but practice for a few minutes until you feel you got the concept down, and then come back and watch the rest of this video, okay? All right, here we want to look at whether composition as an operation is commutative, okay? So here we have two functions, f and g, and we're asked to find both f of g of x as well as g of f of x, okay? I'm actually going to move this over here. All right, so f of g of x would mean take the function g, plug it into f, okay? So that would look like this. And now we simplify. 18 minus 2x squared minus 5. That's going to turn out to be negative 2x squared plus 13. Okay. Now let's go in the other direction. G of f of x means take f of x, plug it into g, which would initially set up like this. Now we simplify. I would square the binomial first. 4x squared minus 20x plus 25. Then I would distribute my negative here. Okay. Combine like terms, and I end up with negative 4x squared plus 20x minus 16. All right, so clearly we can see that these two results are not equal. Right? F of g of x does not equal g of f of x. Okay, and therefore the commutative property does not hold between two functions for compositions.